Hey, what's up guys? This is Akshay from AS Learning, and today in this video we'll be seeing about Llava. Okay, so before going to Llava, you must have heard about GPT-4 and even many of you must be using it. Okay, it is not a free tool as GPT 3.5 Turbo where you can interact with text. It is a paid tool where you need to pay $20 plus taxation, so it goes till $23 per month. Okay, even I have bought GPT-4 and I have been using it, and it is very good. It is really very good. Okay, so it's a paid tool. Okay, as GPT-4 is a multimodal model. Okay, so Llava is an another recently released a multimodal model. Okay, where also you can interact via images. Okay, although it is not available for it is made available openly for the community only for research purposes. Okay, they have a non-commercial license. Okay, so you cannot use it for commercial purposes, but for research purposes you can use the model, and they also have their spaces hosted on Hugging Face. So let's say if you don't have $23 per month, so for your research purposes and for your study, you can use Llava. You don't need to pay $23 for GPT-4. Okay, so let's see before going to Llava's demo, or should we go to Llava's demo first? Okay, let's just see some basic details about Llava, and then we'll go to the space which is using the model. Okay, so currently here we can see that there are not many spaces, and it is just recently made available. Okay, and so it's a open source chatbot trained by fine-tuning Llama Vicuna on GPT generated multimodal instruction following data. It is a auto-regressive language model based on transformer architecture. Okay, so so what is transformer architecture and all these terms? So each term has its own own knowledge required, and if you don't know that, a separate video needs to be watched for what exactly transform architecture is, and let's say what autoregressive language model is. Okay, so but I'll tell about autoregressive language model, like what exactly it is. So when you say that one model or any model is an autoregressive model, it means that it is generating the next token, keeping the previous tokens into consideration. So each word is generated one by one, and once that word is generated, it goes back again to the context of the model, and then the next word again is generated. Okay, so GPT series of OpenAI, they are autoregressive language models. Okay, BERT, for example, is not autoregressive. It works in the way of masking words. Okay, where let's say a certain sentences were there which were masked, and then we try to predict what exact words will be present in that masked patch. Okay, that is how BERT works. Okay, and it's a bidirectional it's a bidirectional transformer architecture model. Okay, so the main purpose for which BERT's architecture is really helpful is not generation of text. Okay, although it can do it, but it is the way it is designed, it is more good for question and I'll say not question answering, I'll say text classification, and then let's say NER, semantic analysis. Okay, for such tasks it is good. When you want question answering generation kind of model, then GPT series, they are trained in that way only. Okay, so the models which are trained in this fashion, they are called as autoregressive model. Okay, so okay, I hope I covered the difference between autoregressive model and how BERT is different from GPT here. Okay, Now next we'll see is transform architecture. It's an encoder decoder based architecture. Okay, you will have to watch a separate video if you don't know what transform architecture is. and how it is different from the traditional sequential architectures, generally in which you design ANN, CNN, LSTMs, RNNs, and all these things. Okay, how they are different from it. Okay, so it was trained in September 2023, that is just last month only. Okay, and it's a 13 billion parameter model. Okay, it is just like giving vision capabilities to Llama. Okay, so Llama is a base model which is pre-trained by Meta. Okay, and Vicona, it is done by lmsys.org. So what is lmsys.org? It's a large language. Okay, let's search only. So it's like a community. It's like a community, I think of Berkeley, I guess. Some students from this one. So what is LMSYS? Let's go to about. Here we can see that it's a large language, a large model systems organization. It's an open research organization founded by students and faculty from UC Berkeley in collaboration with UC SD and CMU. Okay, CMU is Carnegie Mellon. Okay, so it's a open research organization, and the models they have contributed, the most famous one is Vicuna, which was on the base model of Llama, and it is like they, as per their testing, they said that it is 90% with that quality. Okay, now we will go to our Llava. Okay, so Leo Houghton is the guy who has worked on this model. Okay, so you shout out to him, and you shout out to all the people who have been working on this model. Okay, so we saw the date. This is the GitHub page. Okay, here you can this is the page hosted on GitHub of Llava. So they said it is large language and vision assistant, visual instruction fine tuning. Okay, fine. And this is the hosted space on Hugging Face, which we'll be seeing later. Okay, and here they have explained how they have trained the model and all those details. Okay, so we won't be going into depth, but yeah, if you wanna understand how it is done, and let's say even you wanna are into some research work where you want to create or you want to give some vision capabilities to an existing text-based model, so yeah, I think it would be helpful. Okay, then this is the GitHub of Llava. Okay, here also you can have lots of information. These are the benchmarks. Okay, on how so the benchmarks here are visual question answering. Okay, these are different data sets on which we are seeing that the red one is Llava 1.5 and how it is doing good than the other comparative models like Blip2, Instruct Blip2, Qwen, VL Chat. Okay, so here you can read more about these models in depth. Okay, and you also have the research paper. Okay, so this is the research paper associated with Llava 2. Let's open this. I think this is not the link. Okay, let's download it only. That was the citation link, I guess. So even the research side, these things are something even I have been focusing a lot in past 1-2 months. Up till now it was more on the applied side over these years, but now I think we cannot skip research, and that is where you differentiate. So this is the paper. Okay, and yeah, okay, so they have used your visual instruction tuning. Okay, I think this data set which they have used, so we'll see about the data set also. There are 4 types of data sets which they have used. Okay, so now we'll see the data set. So here they have told here is a data set. We'll just see the intended use first. So it's primarily for research. Okay, they have the license here is non-commercial, and yeah, for researchers, for understanding it more, they have kept the intended purpose. So the most popular data sets, that is Common Crawl, Leon, SBU, which have been captured by blip. Okay, then these data sets have been filtered. Okay, and such around 5 lakh entries, 5,58,000 rows are present. Then we have some GPT generated multimodal instruction following data. Okay, and then some another academic task oriented VQA data mixture, and 40k share GPT data. Okay, so around, I guess this is roughly like 10 lakhs 10 lakhs image to text label data. It has been fine-tuned on with the pre-trained base model of Llama. Okay, and for evaluation set, they have used five academic VQA benchmarks and 7 recent benchmarks. Okay, so you must be hearing this term these days, LMM. Previously it was all about LLM, large language model, but now it is large multimodal models, that is LMM, and LVM is large vision model, specific to vision. Okay, now we'll go to the space and see how, like, what is this buzz really about? Is it really good? Okay, so let's first take their example only. Okay, and let's send it and see how it works. So what is unusual about this image is the question, and the answer we are getting is, the unusual aspect of this image is that the man is ironing the clothes while standing on back of a moving car. This is unconventional and potentially dangerous activity, as ironing clothes typically requires a stable and stationary surface. So it was very rightly detected what is unusual here. Okay, then let me upload my own own image. Let me so I've taken this Coca-Cola bottle. Okay, let me clear this history. Let's see how it, okay, here I can clear it up. I'm uploading the Coca-Cola bottle here. Okay, and I'll be asking him, please describe the product. Let's keep it simple. Okay, let's please describe the product. Okay, I won't go more into specific prompting or any short promptings, just let's be simple. Okay, so as you can see that it is telling very rightly that the product is a bottle of Coca-Cola, which is a popular brand of soda. Okay. Let's be more specific. What is the color in the middle of the bottle? Okay, let's see what answer it gives. It gives red, or what it picks in the middle of the bottle. It's right. It is telling very rightly that it is red. Okay, some another way in which we can ask questions is, let's say if you now, because I asked about middle of the bottle, okay, let's say if you want to be more specific, like I want to know what is the color in this dash which is between Coca and Cola, and if just expressing it via text is not proper, so there is another way which they called as visual pointing or visual reference prompting, in which what we do is we, let's say, add an arrow here, or we circle it with some another color, and then we ask him, please tell me what is the color in the circled area in the image. Okay, so this is visual this technique is called visual pointing or visual reference pointing. Okay, so what you can do is, if let's say if any and response is not proper, you can downvote it. Now my response is for right, so I'll upvote it. Okay, so then this data is being used to make it better over the period. Okay, if you find something fishes, then you can do a flag. If you want a regeneration, you can click on the regenerate, and if you want to clear the output, you can click on clear history. Okay, this is not for commercial uses. They have told it very clearly that this is only for non-commercial use only, and this is for academic purposes. Okay, then let's see more about the model. Okay, there's just one version. This is 4-bit quantized version, which is currently available here. Yeah, you can load them. It's available into 2 quantized versions, 4-bit and 8-bit. Okay, and to make it fit for smaller hardwares. If you don't know what model quantization is, I think it's very easy. You can just watch a 10 minutes video, but I'll tell you in short. So it is just like you are lowering down the byte, the memory space of the data type used in training the model. Let's say if it's a int or a float, and let's say it's of heavy byte range, so you are lowering down to it to a 4-bit or a 8-bit thing to make it available and suitable for smaller hardwares, so that the computation and the space required also becomes less. Okay, yeah. So they have made it available for 4-bit and 8-bit. Okay, so quantized versions of models are also available. There are many people who are working a lot on this. One very popular person on Hugging Face is the Bloke. So his is very active in quantizing the base versions of the model, so that they are available for smaller hardwares or machines which have less RAM. Okay, and such things. Okay, so this was a quick intro about what Llava is and how you can use it. Okay, and yeah, if you want to read more about it, I have told you about the paper. If you really want to understand how it was trained and all by a team, you can read about this paper. If you want to access the model, you have the access of GitHub repo. Okay, once the comparison benchmarks in much more detail, the links are here. Okay, so yeah, this is what I had in this video. If you like the video or learn something, do give it a like. It really motivates, and stay tuned to AS for more such amazing tech stuff. Take care. Peace out.